so looking at this exercise, we have a solution containing equal masses of glycerol and water, and we're given a density. We're asked to calculate both the molality, the molality, the mole fraction, and the molarity. All right, well, let's see what we have. We have, in the given, okay, so equal masses. They don't tell us what those are. Probably should assume something. So let's assume that we have 100 grams. So if I have equal masses, I have 50 grams of the glycerol, C3H8O3, and 50 grams of water. And we're given that the density is equal to 1.10 grams per milliliter. The first thing we're asked for is the molality of the glycerol. So they're telling us that the glycerol is the solute. So the molality is going to be the moles of the glycerol over the kilograms of the solvent, which is water. All right. Well, from our assumption, we have enough to calculate the moles and also the kilograms. So let's do that. Change my pen color. So if I have 50 grams of C3H8O times however many grams there are in 1 mole of the C3H8O, that will, O3, geez. O3. So I'm going to calculate the molar mass. So we have a molar mass of 92.11. Using that, we can calculate the moles of the glycerol, 54283. Now, I made the assumption of the mass, so it's really assumed to be exact, but because our density is given in 3 significant figures, I'm just going to round the answer to the 3 significant figures. So the molality of the C3H8O3 is going to be the moles of the glycerol over the kilograms of the solvent. It's given in grams, so I have to convert grams in a kilogram. Okay, so doing that math, I should get a molality of 10.9, molality C3H8O3. By the way, that is rounded from 10.857 to 10.9. Okay, so let's go on and see what we need to do to calculate the mole fraction. We're going to remember that I calculated that there was 0.54283 moles of the glycerol. So now we're looking for the mole fraction. Okay. Remembering the definition, and again, it's important to remember these definitions. Looking for the mole fraction of glycerol, so it's going to be the moles of C3H8O3 over the total moles in the solution, which would be the moles of the glycerol plus the moles of the water. From earlier, the moles of C3H8O3 was 0.54283. So now I just need to get the moles of water. I assume that there were 50 grams times 18.2 grams of H2O in 1 mole of H2O. This will give me the moles of H2O. That gives me 0.027747. So my X mole fraction of my glycerol is going to be the 5. That's not quite right, wait. Oh, you know what I did? I'm sorry. This number's not right. That was silly. How about 2.7747? That makes more sense. So my mole fraction is going to be the moles of glycerol over the moles of glycerol plus the moles of the water. And I get a mole fraction of 63625. Rounding it to 3 significant figures should be 0.164. So let's move on to the last problem, which is calculating the molarity of this glycerol solution. I keep hitting the wrong things. All right, now I think I got it. Goodness. All right, so calculating the molarity. So now I'm on to part C. I want the molarity. What's the definition of the molarity? Okay, it is the moles of C3H8O3 liters of solution. Okay, well, I know my moles of my glycerol is the 0.54283 moles. Liters of solution. How might I get the volume of the solution? Well, if you remember, we assumed that we had 100 grams of the solution. We're given a density. If I take that mass of the solution and I use the density, can I get to the liters of the solution? Yes. And once I get the liters of the solution, then the molarity of the solution is going to be equal to those moles of the solute over the liters of the solution. So liters of solution, I calculate 0.0909, 0.09099, and put that in my calculator with the moles. I get a molarity of 5.97113, which is 5.97 molarity of the C3H8O3. There you have it.